Okay, now for method 2. For method 2, what I'm going to do is I'm going to look at all of these denominators, and I can make a little list, I can make a little chart of them. I'm going to have a denominator A, denominator B, denominator 2A, denominator 2B. So those are all of them. Now A can't be broken down anymore, it's just A. Same with B. So when I work my way down through the list, there's an A, there's a B, okay, and I still need one more thing, times 2, times 2, like that. So when I figure out what my least common denominator is, it's going to include a single A, it's going to include a single B, it's going to include the number 2, and most likely I'll rearrange the order of this. I'll have 2AB, because I can do that with multiplication. I can rearrange the order in any convenient way. So now that I know what my least common denominator is, I'm going to use it on the fraction, like this. I'm going to take that 2AB and I'm going to write it so that basically I'm taking this entire complex fraction and I'm multiplying it by a form of 1 that I created out of the least common denominator, and I'm going to distribute 2AB through this first pair of fractions. So it's going to be 2AB times 1 over A plus 2AB times 1 over B. And what will happen then, when I do that distribution, is I'll have 2B plus 2A, and it's going to be divided by B squared minus A squared. Okay, because like I said, I took 2AB and I multiplied it by 1 over A. That means the 2AB gets divided by A, and all that's left is 2B. Then I still have to add to the second fraction, 2AB times 1 over B is going to cross out B and leave 2A. In the denominator, 2AB times B over 2A, the 2 and the A will disappear, the B will stay, and I'll get B squared. So I've got that. And I'm going to subtract A over 2B times 2AB, the 2 and the B disappear this time, and the A remains. Now look out here, there's some factoring and reduction that can happen here. I'm going to have 2B plus A in the numerator. In the denominator, I'll have B minus A and B plus A. So when I cross those out, I end up in the same place as I did doing it the other way. And the one thing that I need to do is to go back and check these denominators and say, okay, this has the same restriction as the previous version of the problem did, that A is not allowed to equal 0, B is not allowed to equal 0, and now I have a complete answer. And if we were going to be really, really careful about it, we don't want B to equal A either. So we could add one more note here, that B is not allowed to equal A. So that gives us a really complete answer.